Thank you. Thank you. So I'm going to talk to you about the future of software development, which means I'm going to make some predictions. And here they are. Hopefully they will be sufficiently crazy and future-y to get your attention. So the first one is, in the future, there will be no such thing as having a job in software development. That entire concept will be obsolete. No longer will you be employed by a company that pays you to spend time sitting somewhere and perhaps writing code. You won't even be paid for the act of typing the code. Part of that is because all software will be open source in the future. Have I lost you yet? No? Okay, good. All software will be open source. There will be a blockchain-based token economy that drives this open source software ecosystem. Now you're thinking, oh, this is bullshit. Yeah, I'm not with you. You may leave now if you do not want to listen to the rest of it. But I'm serious, and I'm going to try and show you some ways that this is maybe not quite as bullshitty as it sounds. But this token economy will finally, once and for all, figure out a real funding model for open source software development. Those of us who've been in open source for a long time have been waiting for this to happen. So because of these factors, programmers won't be paid to sit and work by the hour. As I mentioned, they'll be paid for contribution. Contribution could be source code commits. It could be replying to help requests on forums. It could be adding tests to code, writing documentation. All of this on this blockchain-based token economy. And many software features, if not most or all software features, will either be implemented by or assisted by and I have to be very careful because Hila was just in here talking about the limits of automation, but assisted by coding robots, artificial intelligence agents, artificially intelligent agents that live out on the internet and work within the context of this token-based economy. And we won't deploy to servers anymore at all. We will deploy instead to decentralized distributed virtual machines that run across computers on the web, and maybe even your phones and your watches and your IoT devices that will have been hacked, are already hacked, but they'll start being used for that instead of spying on you. And smart developers in this futuristic world will not just sit and try to write the features themselves, but they'll code gangs of robots that go out into the world. They'll automate things, maybe not artificially intelligent robots, but we'll have this open source token-based economy. All software will be open source, which means if there's a security flaw released into the wild, the first person who writes the code that figures out how to patch it for everyone gets their contributions accepted and gets rich in a day. So things will be very, very different. Now, none of this is probably true, of course. We can't predict the future, not to this level of accuracy. And of course, I'm talking about 10, 15, 20 years into the future. It's impossible to predict. We do know that things are going to be really different. And we know that there are a bunch of interesting forces in the world right now that show that some of these things could actually be possible. So I'm going to talk about those forces and hopefully put some ideas in your heads and give you some things to think about and learn today, which perhaps prepare you for the future. The future is here, though. As a person who's getting close to old, and if you're 20, I am old, and if you're 30, I'm not. If you're 50, I'm young. But as someone who's almost old, I grew up in the 70s and 80s watching TV shows like The Jetsons, where a bunch of stuff seemed impossible. It seemed like it would never actually happen in our lifetimes. But I'm starting to see these things come true today. Back to the Amazon, the Bezos announcement that autonomous drones would be doing delivery at scale by next year, I think it was. That seemed crazy, even just in 2013 or whenever he made that prediction. It does not seem crazy now. It seems like we just barely missed it. And I remember people thought that was an April Fool's joke just a few years ago. It was not. I work as an investor, so I spend a lot of time looking at startups. And in the recent past, I have seen startups that do things like 3D print vehicles that are then autonomous to drive people around campuses at schools and government institutions. 3D print vehicles. You can 3D print rockets. I can actually afford to buy my own satellite, 3D print a rocket engine, pay to have my satellite propelled into space, and run on it my own custom code that I write in Java to do things like monitor the Earth. I can actually afford to do that today. It's not something I'm interested in doing, but it's something that I can afford. I would not have believed this if you told me this even 5 years ago, but it is possible. Even these simple things like smart speakers. There is a battle to see who wins the smart speaker space. Speakers are smart, really? But that sounds like Star Trek stuff. You can just talk and stuff happens in your house. You know, we sort of forget. Imagine if this is how you learned chemistry when you were a child. I'm going to turn off the sound. Augmented reality for kids to learn chemistry, actually interacting with things like this. Again, stuff that just didn't seem like it would have been possible. This would look like something that was 3D rendered in a studio just a few years ago, and now it's something that kids might actually use. Yes, Office, I do want to update right now. Thank you. If you can just hold on for another hour, I'm going to go ahead and update PowerPoint. It's not all good either. So in the future that has arrived, The Walking Dead has come true. And you know, I put this up here as a joke, but it is actually interesting if you think about what technology has caused us as a species to do. Like go out and get on a train and look around you. Everyone's looking at your phones. About 5% of you in this room are looking at your phones. I'm looking at you now. But this has significantly changed how humans interact. It's an amazing, effective technology. But I do even remember a point where just like the idea of having the internet available in your pocket, that seemed impossible. Like you used to have to go to dinner and argue about a fact and not be able to look it up. Not too long ago, it's amazing. And here's something that I saw at work that just, it brought all this home for me, that the crop that is the most valuable one of the future is not actually the crop, but the knowledge harvested from all of the drones that will be out collecting information about the crops and automating crop management. That is scary and crazy and awesome. I met one startup in Israel that has autonomous drone swarms. That's the business they're in, autonomous drone swarms. So you can program a swarm of drones and like set them loose on a building and say, create a 3D model of this. And depending on how many drones you have, it's faster because you scale by adding drones. So if you had thousands of drones, they would just terrify everyone in the immediate area and come back immediately with a 3D model. Amazing. So, you know, all of this stuff, I think you'll agree, if you're anywhere close to my age, this stuff didn't seem possible. It seemed like, you know, maybe sometime before we die, we'll see some of these things. And they make some of our dreams really seem quaint. But as someone who spends a lot of time out in the world talking to software developers, talking to startups, because I do venture capital, I'm constantly on the lookout for people taking this sort of futuristic thinking and applying it to what we do. Like, what about us? We're the ones that are actually creating all this stuff in a lot of cases, the software developers. Well, here's what we have. These are our tools. How many of you use Java, JavaScript, or .NET in your work? So almost everyone. Basically, those tools were invented by these two people. These are the inventors of Simula, Ole Johan Dahl and Kristen Nygaard. This was created in 1965, Simula. And here is a code sample. It doesn't matter if you can read the code, but if you squint, you can see it. And honestly, if you go to Simula on Wikipedia, that's where this came from, so you can read along. Objects, classes, constructors, garbage collection, coroutines, so many things in Simula that if you were to describe, well, what are the features of JavaScript today, or what are the features of Java, you'd say these things. You might not even get all of them for all of the languages we use today. 1965. That's even before I was born. So, okay, those are the old languages. The smart people are doing these things, you know, Scala, Elixir, Haskell, of course, that's the one that all the really smart people use, Clojure. This is the future. The future is functional, right? Well, functional programming, 60 years ago, Lisp, that's where this stuff came from. And you might say, okay, well, that's not really true because a lot of it came from like the Scheme crowd. All right, so that was the 70s, you know. The point is, the programming language technology that we are still trying to master and we're still evangelizing today is from the 60s and 70s, and even the 50s in the case of some of the ideas of Lisp. We've got this whole crazy thing happening with containers, orchestration, serverless computing. Exciting. I'm guessing a lot of you are really into this right now, and I agree, it's exciting, it's good stuff. But a friend of mine, Francesco Cesarini, famously said at one point, every sufficiently complicated microservices implementation is a re-implementation of Erlang. So hello, Joe, this is Erlang from 1986. That was when Erlang was created. The sad thing is, I've been one of these people that has created these architectures. I've been very proud of them. In fact, one of said architectures I would say is the best thing I've ever made in my career. It's just nowhere near what you just get if you install Erlang. Like brew install Erlang on your Mac, and you have something better than the best thing I've ever created since 1986. It's pretty sad. So this is a graph from the Standish Chaos Report. This was from 2012. You might be thinking, why are you showing me 6-year-old data? But you'll get it in a second. What Standish does, the Standish group goes out and they survey large companies, large organizations, and they ask them about their software projects. And they collect a bunch of interesting information. And the thing that we most often see is this, which is successful, challenged, and failed projects. We see the percentage of projects that fit those categories. Now, successful is what you would expect. Failed is sort of what you'd expect. Challenged, though, means significantly over time or over budget, which to me means failed, too, because I don't feel like I succeeded after that. I think we can probably all recognize that this is pretty much the right distribution if you think about software projects across the industry. Not your projects, of course, but the ones you hear about, right? So here is the really sad thing. If you graph that over many years, it looks something like this. Ugh. So everything we're doing, like it helps us and we enjoy our lives. It's not that there's no value, but you don't see ever any time that there is any significant bump in the ability for us as an industry to deliver successful software projects. Nothing we've done so far has made a dent. Maybe since the 60s. I bet it was probably easier after Lisp, right? So we keep doing the same thing, and we keep hoping it's going to be better. And I think a lot of that is because we're hovering around what we understand, and we're hovering around local maxima. Here's an example of someone who you would not expect that from, and who in many ways hasn't. This is Chris Wanstroth. He's one of the co-founders and the last CEO of GitHub before the sale of GitHub to Microsoft. He tweeted a few years ago, and he deleted all of his tweets when the acquisition was announced, so I can't actually directly quote it, but he tweeted something like, software developers, humans will always be involved in software development, and they will always be the ones that create software. It's never going to be robots, because software is a creative activity. To which I say, look at this painting. This is generated by a computer. And listen to this. Don't worry, we're not going to listen to the whole thing. This is an AI-composed pop song. It's not any worse than anything else on the radio, is it? But we're clearly at an interesting point with a bunch of convening technologies and a bunch of convening capabilities. It's not just that serverless computing has come along. It's not just that AI has been democratized. But right now, there are a bunch of factors that are coming together that are making new things possible that haven't been possible in the past. And so it is possible, I think, that we can move from this incremental approach to improving and changing how we do software development to something that actually makes a dent for the first time in 60 years. So I'm going to start by talking about serverless. And I didn't mention all those. I'm going to talk about the things on that list. And I don't want to read a bulleted list to you. So we start with microservices. That's all the rage now, and it has been for several years. And I'm one of the people who's talked about this a lot. I practiced immutable infrastructure in the last job where I actually wrote code. And it was hugely influential on me and hugely influential on that architecture I was talking about that was the best thing that I've ever created in software. But what are microservices? They're really just small, specialized Unix-like processes. They're like processes in a Unix OS. They run, they do one thing, and that's sort of the idea of them, right? Small things that you can reason about separately. And I don't need to actually explain that because all of you know what microservices are because people are excited for this very reason, the separation and the focus of each of them. So once you have that concept, you need a way to separate memory, have different address spaces, some sort of deployment model, and that's where containerization comes along. And all these things get mixed up in everyone's heads because once we come up with a name for something, it ruins it. But you have great technologies like Docker that really are incrementally making things better for us and how we deploy and manage software. And they follow very nicely, but aren't dependent at all on the concept of microservices. They give us a nice model for deploying and managing those microservices. And now we need a way to bundle them all together and manage suites of things. And that's where you end up with like orchestration, so Kubernetes and the like. And so that's how you manage multiple processes that interact. You can bundle things up into full applications and systems based on a bunch of tiny little pieces that work together and not have chaos. So all of this, this ever so slowly, I'd say, leads us to a model where we can stop thinking about servers at all. And that's where we have stuff like functions as a service, AWS Lambda, Azure functions, et cetera. This is what we say when we mean serverless. The servers just sink into the scenery at that point, and you're thinking about code. Someone's still managing the thing, and there's still servers, obviously. But the servers, from the developer's perspective, go away. So it's sort of like what Sun was getting at back in the 90s and early 2000s. And some of you were old enough to be nodding your heads right now. The network is the computer. Well, you know what? Sun, it really wasn't back then, was it? It wasn't at all. The computer was the huge Sun server, but now it sort of is. Because I know back in the 90s, I loved Sun and Solaris, but the computer was still the computer. We're getting closer and closer now, though. But what we're doing is we're building an operating system. And that's why I used those analogies before, the processes of microservices and address spaces or containers, et cetera. So what else might we want to build into our operating system? I'm not going to go very deeply through this list, but one thing we might want is some sort of way to declare how these services talk to each other. What are the type signatures of services? What are the inputs and outputs? And in the world of network computing, how much does it cost to run one? Are they pure functions? Because we say function as a service, but in actuality, many of the functions as a service aren't actually functions. They're procedures that have side effects. So if they're pure functions, what does that mean? Pure functions on the web. What if we could declare all of this stuff about all of the functions on the internet? And that's what this project, Functions as a Service Lang, is, FASLang, open source thing on GitHub. By the way, at the end of the talk, I have a link to links of all the things that I mentioned here. So don't bother trying to take notes. Should have told you that earlier, sorry. So with FASLang, you don't care what the vendor is. You remove the cloud dependence. You have FASLang compliant gateways. It's all open source. You have all this stuff specified in terms of input and output types, whether it can be run asynchronously, et cetera, et cetera. And as I said, you don't care if it's running on Lambda or Google or Microsoft. You just run things. That's pretty cool. That's definitely an incremental step farther than where we are right now. Any of you doing functions as a service in your day jobs? Very few of you. So I'm already in the future for some of you. Mission accomplished. Great. Now imagine that because you have the ability to declare which things are pure functions, don't have side effects, and you know all the input and output types, you could even discover and declare which functions could be pipelined together, the way, for example, Erlang functions are pipelined together. And that's part of the beauty of functional programming, right? But pipelined network functions, which means if they're running in the same provider, you as the client don't have to call out, get the result, call out, get the result, call out, get the result. Maybe there is a way to pipe them all together in a way that is efficient In fact, maybe there's a way to pipe them all together on the same box so they're not even going over a network anywhere. Interesting concepts. Once you've done that, you've got all this type of information. Someone should just catalog it so that there's a standard library of these things that exist. And it should be easy to call them because you've got all of this stuff standardized, right? So this is it's called stdlib because the idea is to create the equivalent of the Unix C standard library for the internet. This, as a warning, is a company, so you don't want to just declare that we're done and follow what they do, but the ideas are interesting. They're friends of mine. So here's some example code calling it. And if you just ignore all the JavaScript boilerplate garbage and look at the one line that means something, you can see how you call it. Lib is the namespace for the whole thing, and then you've got one person's namespace there and a function that they've defined. You just call it. That's how it works. So you can imagine that happening at scale. Lots of messes you can also imagine, right? But someone needs to be doing this, and probably lots of people need to be doing this so that we can actually get here sooner or later, because this is like Department of the Near Future kind of futuristic talk, right? This is just, it's stupid that we can't do this yet. It's been too many years that it was possible. But let's talk about real serverless computing, because those all have servers. That's not real serverless computing. That's just a stupid marketing name. Now there's a picture of the Bitcoin logo here, so that should scare you. I'm going to explain some concepts to you, and it may be that all you get from this talk is understanding what blockchain means, and I'm okay with that because no one understands what blockchain means, right? So blockchain technology, it is stupid that anyone ever says blockchain technology. That's like saying, I've got a new startup, it's a linked list startup. Yeah? Will you fund my linked list startup? No. What is a blockchain? It is a data structure, and it basically is a linked list, but it is a cryptographically signed linked list that cannot be tampered with after the fact. That's it. And it looks something like this. So there's block 0. You can see there's a pointer to previous hash, which is the previous thing in the list. The next one, the previous hash, points to the hash of block 0, and so on and so on. Each one has data. Now the hash is actually a cryptographic hash of the full block, all of the data in it, which means you can't change the data, because if you do, then the pointer will point to nothing, because the hash is different. That's it, blockchain. Everybody get it? Yeah, good. Now you know what that means. You're better than most programmers. In order to get Bitcoin to work, again, this is one of those fundamental things you have to know, is the blockchain isn't quite enough. The blockchain, I left out one word for what blockchain is. It's a data structure, but it's a distributed one, so it can live on a lot of different computers. Now the problem with it, though, is if we're maintaining a blockchain together, we can both agree that there's this hashing concept and write all the code to work on it. But if I decide to add a block to my version of the blockchain and you add a different block to yours, then we're out of sync, so you have no consensus, and the whole thing's useless. So the magic of Bitcoin is, and this is really the essence of what's interesting about Bitcoin and why Bitcoin is actually not garbage. Because all the stuff you hear about cryptocurrency, most of it is trash. It's noise. The prices have descended, and for good reason. But the technology and the ideas are not garbage at all. They're amazing and transformational. Proof of work is how we do consensus in Bitcoin. And basically, we are looking to gain security of the distributed ledger, which is the Bitcoin blockchain that's sitting on thousands of computers in the world. We need to do this in such a way that someone can't go decide, well, I'm just going to add some blocks that say that you transferred me a bunch of Bitcoins and be rich. You can't do that. And you can't do it because of a simple thing. Satoshi, who is some anonymous person who created Bitcoin, created a protocol that is actually a technical protocol which relies on the self-preservation instincts and greed of human beings to be secure. And so you'll hear this proof of work thing. Basically what happens is when a request for appending data to the blockchain goes out to the network, all of the computers in the network are competing to be the first one to answer a ridiculous, useless question which requires expensive computation. It is really hard to compute and trivial to prove that it's right, trivial to validate. And what that means is that they're just crunching away, fighting with each other in order to be the first one to answer just a stupid cryptographic quiz, basically, a numeric quiz. When they answer the quiz and they're the first one on the network to do it, they're awarded Bitcoin. And that's worth something from 0 to 20,000 US dollars, depending on what day it is. Because of that basic fact, the fact that they're competing to do it, it has led many people to spend hundreds of millions of dollars both stacking up servers to fight this war and try to win Bitcoin, and even to create industries around hardware that's specialized for it. So because there's so much potential value in being the first one to solve this mathematical puzzle each time, it becomes prohibitively expensive to game the system. You can't unless you have, for example, all of the money of the Chinese government. Maybe then you could. So that's kind of scary because they might do it. Who knows? If I were the Chinese government, I would probably take over Bitcoin. So that's how it works. That's the whole thing. That's what proof of work means. I'm not going to go through this, but basically there are economic incentives that every miner has, and it drives the whole protocol towards security as the basic goal of the protocol. So the goal is about, or the protocol is about baking incentives into a technical protocol so that the protocol is dependent on the incentives to actually run. It's part of how it works. You can't do anything with Bitcoin without people greedily trying to earn Bitcoin to validate your transactions. If I send you money, someone's going to get paid because they put it on the blockchain. They were the first one to do it. The incentives work really, really well. As I was saying, we've spent hundreds of millions of dollars trying to be the first one to get the Bitcoins every time. And it has been valuable for people who've done it. So, we've done bad things to the environment as a result. Bitcoin miners are using, it's different every time you look, but there have been times when Bitcoin miners have used as much energy as the country of Ireland, the whole country, for example. That's scary. Now think back to the Walking Dead people with their iPhones and their Android phones from before. It's amazing what we can make people do with technology. So what if, rather than making people solve a stupid, useless math problem, you could get them to do something valuable? Because no one, even the people who created Bitcoin, think that solving the math problem is valuable. It's just a hoop you have to jump through in order to make the protocol work. What if we could build protocols inspired by that idea, but where the equivalent of proof of work and mining leads to something of value? So an example of this is an unreleased thing called Filecoin. You can read the white paper. That's a link to it there, but as I said, there's a link to all of it at the end. Rather than useless stuff, though, what Filecoin is doing is it is creating a distributed file sharing and storage network, sort of like Dropbox, OneDrive, Google Drive, etc. So it would be a competition to that. But it does this in a decentralized way where, rather than proof of work, the outcomes that they force you to do through greed, or they encourage you to do, and they end up forcing you to do through greed, improve the performance of the network. So it is possible, if you imagine what we've done in terms of using up energy in the world, Filecoin's goal is to drive people toward making the best file service that has ever existed, that is resilient to network partitions, to government censorship. And they do that by basically encoding stuff into the protocol so that if someone requests something, if you're a file server and someone's requesting a chunk of a file and you have it and you're close to them, you get paid more. So you're more likely to earn the Filecoin. If you can prove that you're actually storing the file, or you have to prove that you're actually storing the file in order to get it, and you also have to prove that you have a replica of the file on its own physical disk. So the reason that you have to prove that you're storing the file is, and you need to have stored it over time, is they want to avoid stuff like a request goes out to the network and the Filecoin miner just goes and gets it from another miner and then serves it to you and gets paid, that sort of thing. All of these things put together create literally a file serving and storage protocol that, that forces the files to be closer to the requesters and to be more redundant and resilient. And it's literally baked into the protocol. It's sort of like, WebDAV, but built-in incentives to capitalize on greed. So I highly recommend you read this paper. It's not difficult to read, amazingly so. If you read it, you will understand sort of like the cryptographic backbones to these things, and you can imagine more such protocols coming to life, where the internet could potentially be reinvented. If we're talking about files, storage and serving, sharing, that's just one protocol of the internet. You could imagine doing it with email, with chat, with all different types of communication, where the incentives and the behavior that you want out of the system are part of the protocol, and the actors of the system rely on their self-preservation and greed instincts to create a better experience for everyone involved. Okay, so this is just some background information on blockchain, which leads us to the concept of true serverless computing. So if you look at Ethereum, which is the second major altcoin that came around, or the first major altcoin that came around post Bitcoin that really meant anything, it's really confusing because the first time you look at it, you say, okay, it's just another coin, it's another cryptocurrency. And then when you talk to someone about what it means, they will tell you it's a virtual machine for running programs. And it's just like, what do you mean? Turns out Bitcoin itself is even a virtual machine, but a very, very simple, stupid one, and was the inspiration of this. But with Ethereum, you can not only trade cryptocurrencies, and there are proof of work, proof of stake sort of algorithms to make sure that the network is secure, but you can execute arbitrary code. And I say arbitrary with air quotes because there are obvious limitations. So the code, part of what it can do, and the primary purpose, they call them smart contracts, but it really just looks like JavaScript code, as you can see here. The sort of basic hello world first example that you get to, well, this is hello world. The second example after hello world would be that in 20 lines of code, you can implement your own cryptocurrency in Ethereum and create a contract around people getting paid in an atomic way on a distributed blockchain. Now, the interesting thing about running code like this, you can literally compile and deploy this into Ethereum. Ethereum is not a thing that runs on one computer. It's a thing that runs on thousands of computers around the world, exactly like Bitcoin. And the Ethereum virtual machine runs on those thousands of computers, which means if I write some code in a contract like this that specifies, for example, let's say I codify how open source protocols work, so how code contribution pays me, as per my first example. I could put that in a contract that we could all read, understand, and agree is okay to use. I could then deploy it into Ethereum. It runs on everyone else's computer. I have no concept of where, but it does it in a cryptographically secure way. And most importantly, it does it in a way that I can't tamper with the code. So I, even as the author, cannot change the code of the contract that I've written and I'm now running in this Ethereum virtual machine. If we want to change the code, we have to deploy new code and start referring to and using the new code, but it has to be explicit for everyone. And the techniques involved in making Bitcoin work make this ability to execute code in a tamper-proof fashion also work. So it is secure. We've proven it already. It is the world's slowest, crappiest virtual machine right now, but it has some properties that make it worth using. And those are the ones I was talking about, tamper-proof and the ability to transfer value as part of your contracts. But it really, really sucks as a virtual machine if you think about it that way. But what if it didn't? Because you know what? At some point, it's not. At some point, it's not going to be the world's slowest virtual machine. It's going to be something fast and usable. And it might not be called Ethereum then. But people are operating and iterating so fast in this world that we're going to get to a point where we can do some amazing things. We have a VM. Filecoin gives us parts of a file system. Parity Technologies gives you a way to connect VMs together. And then there's a whole project called Zeppelin OS that allows you to do things like have package management for the operating system and install and upgrade smart contracts that talk to each other, sort of like what the standard lib thing does for the internet, does for these sorts of technologies. And what you have at the end is real serverless computing. So an interesting point here is the blockchain projects are all open source because the value is not in the code. And this is an interesting pointer to how maybe all software in the future could be open source. There is no need to hide the source code. And in fact, if you don't publish the source code, no one will use your cryptocurrency in your network. And keep that in mind. If someone asks you to use their network and it's not all open source, you shouldn't. There was a time when the internet was like that, by the way. You wouldn't use anything if you couldn't see the source code. But look here. Filecoin raised $257 million in their initial coin offering because of the potential value of these ideas and the crazy greed of investors. But now the network itself is something you can buy into and you can use, and people will participate because there's value in Filecoins already. So now they just need to actually launch the project. But the source code is not at all the thing of value. And it's not so radical that all this stuff is open source because, in fact, you can actually think about it yourself. What you are running your companies on today is probably primarily open source software. And you're probably starting to contribute to open source software at work if you haven't already. I mean, I work at Microsoft and we do it at scale, and you should all be surprised about that. Pleasantly surprised, but we do. And I'm one of those open source Microsoft haters from the 90s. I'm amazed to see that that's true. But it leads me to believe that we're getting really close to all software really being open source. And eventually, you're going to kind of seem dumb if it feels like you're trying to hide your source code because that's your IP. Like I can imagine as an investor, someone telling me that their source code is private and kind of laughing at them like, silly kid, your source code isn't worth anything. How do we fund software development then? Well, one way would be stuff like Filecoin, where you have networks, the network has value, and that funds the development because the creators of the idea get the money, the initial money for it, and then the network lives on. You also have stuff like the Gitcoin project, which is a way to use cryptocurrencies to have bounties and pay people for the work that they do. What we've done from basically the early 2000s until now is we've had corporate sponsorship. So like we sponsor a bunch of stuff at Microsoft, and I'm sure many of your companies do now. And then one of particular interest to me, and something I sort of referenced at the beginning, OSCoin is a nascent project similar to Filecoin, but rather than building a protocol for serving files, they're building out a protocol for operating open source. So imagine being able to do an initial coin offering, like an equity buy-in to your open source project. A bunch of players get in and they buy equity in it, and then there are codified rules. So it's not just that you're on a mailing list over here and on a bug tracker over here, but somehow they're all connected and codified in a way where if I actually add value to the project, I actually get value through some sort of contract that we can't tamper with. That's what OSCoin is trying to do. So speaking of open source and what it has done for the world, to me, the biggest change that I've seen in my career is not all this tech stuff, but it is the convergence on open source as a style of development. And in fact, it has probably influenced all of us before we start actually doing all the open source everything kind of work. We get used to operating in a collaborative environment where people are all over the world. If you do a pull request and someone comments and makes suggestions, you might know their GitHub handle, and I'm just assuming GitHub for this conversation. It could be something else. You might not know. You really just judge it based on what they said and whether or not you think it's valid. If someone makes a pull request on your code, hopefully the same thing is true. We don't really care. We don't even know sometimes if it's a human being. Even if it does say GitHub/Chad is the person that commented, how do you know it was me? How do you know it wasn't a script that I wrote that created some sort of pull request on your code or put a troll face on a diff that you made and that sort of thing? So the first example I saw of this was a company called Sneak. And what they did, it changed how I thought about what's possible with open source development and bots. So Snyk scans for new security vulnerabilities in open source software that your software may depend on. And they have their own database, and they also use all the public databases of vulnerabilities. And when a vulnerability comes along, they automate immediately a pull request against your code to upgrade your code to the safe version of the library that you're using. And the first time I saw this, it just sort of blew me away. And the reason it blew me away wasn't that they could figure out there was a problem and submit a diff to me. It was that they created a pull request. I could look at the pull request, I could look at the diff, and I could just say, yep, looks good. Pull requests added this step that make me okay with robots working on my code. I don't want a robot going in and changing stuff, but if a robot suggests it and I'm already doing code reviews, I'm pretty happy about that. And Snyk is an interesting, I think, foreshadowing of what's possible. So next possible step then is if we're saying we don't know if there are humans touching our code, well, there may be AIs touching our code, right? AI is getting easier and easier to do. And a warning to you, it's not only getting easier to do, but if you're a software developer and you don't know how to do machine learning, it's getting more necessary to understand too. So, easy and necessary to know, sort of like data literacy is part of what you need to actually have on your list if you want to stay employed. But, services like AutoML services from the various providers where they use ML to drive the creation of ML models, all of this can only get faster and faster. We don't know where it will go. And this leads to programs that evolve. Now, it might not be that the program itself, the source code gets fully written for you. And if you were in the previous talk in this room, you heard about limitations from one of the world's leading practitioners that's saying, I don't know how far it can go. Not very far is what Hila says. However, just, let's look at the facts right now. All of these ML models that are driving all this stuff you're using today, no one programmed them. So it might not be that we go tell the robot, go write me a web app, but we are saying, hey, robot, make it so you can recognize faces. I don't want to have to program that because it's impossible. So programs are already being created by the machines, but just in small bits. And I'm okay with that because you know what? Small bits are the way you should build software anyway, right? Let's not throw out what we know about great software development just because we're getting into AI. So eventually we will train our programs, and when that happens, it opens up all sorts of questions like how do we audit that code? How do we debug that code? Oh my God, it's a nightmare, or it's a whole field. Probably it's a whole field is the way to think of it, because nightmare means you're like me and you're just going to give up. We also have to worry about stuff like, more than before, we have to worry about bias in our own software. So, ethics and AI, like when did you hear 10 years ago about ethical software development? Like just a little bit. And when you heard about it, you kind of thought, well, that person's kind of crazy crusader. I understand what they're saying, but I don't really get why it's a big deal right now. So, now maybe we will write software that writes software. Maybe the robots really will create software. For the first time, we have these massive code repositories where we can actually learn about code. So, GitHub, SourceForge existed before too, but GitHub, massive code repository. So there's a bunch of research going into deep code and program synthesis on the back of this new asset that didn't exist before. Then you have companies like Sourced creating this open source Babelfish whose job is to take all of the programming languages of the world and generate a unified abstract syntax tree so we can reason about them all the same way. So then we have the syntax, then we start thinking about how we represent that in ways that computers can actually understand semantically. And if you want to know more about this, ml4code.github.io is the place to go. Again, in my links, this is Miltos Alamanis, a colleague of mine who is doing a lot of work here. But also this is just a great place to learn about program synthesis. And it's not just code that we have available to us. So think about GitHub and pull requests. We have repository activity. We have code churn. We have comments. We have frowny faces and comments about lines in source code. It's amazing what we have. And it leads us to be able to do things that are truly advanced. Like this might look like a telesense, but this is Codota from Israel, which happens to be colleagues of Hila, doing amazing code completion, where you type one little token and it can expand all these different possible patterns, and it doesn't require that you start with any known piece of code. This is just arbitrary text, and it's using the mined GitHub repositories. So find Hila on the break if you want to know more about these concepts. Okay, so I've said all this crazy stuff. What should you do with this? Like, you probably can't just sit back and wait for the robots. You cannot go wrong right now if in your daily job you just focus on raising the level of abstraction of your work. It's clear that the levels of abstraction will raise, and if you're down in the weeds, whatever that means to you, you're probably in the wrong spot right now. So get yourself out of it. Decoupling, you can't go wrong with that either. This doesn't sound very futuristic, but I bet a lot of you still need to hear it, and if not, your teammates do. So if you are decoupled, if your code is decoupled, if that is like one of the fights that you fight, then you will be ready for bits and pieces, small bits and pieces, to be automated by the robots and to move into the future. Automate everything you can right now. Don't write this blockchain off as garbage, this blockchain technology stuff off as garbage. Also, don't go buy a bunch of Bitcoin unless you want to, but I'm not telling you to do that. Remember data literacy. It is critical. Every problem might be a machine learning problem from here on out. And with that, I give you my thanks and the link below so that you can see links to all this stuff I've been talking about. And thank you very much.